This video is another review topic on angles, triangles, and the Pythagorean Theorem. I do want to ask you to please watch all of the videos in their entirety. I do put them on YouTube so that you can speed them up if you find that I'm going too slow or it's boring or it's all review, but you never know when I'm going to say that one thing that's going to click and make it make sense for you for the first time if there's some topic you've always struggled with. Alright, moving on. First off, with a triangle, the measures of the three angles in a triangle, any old triangle, are going to add up to 180 degrees. Now this is technically the official way you would write that, the measure of angle A, the measure of angle B, the measure of angle C. Rather than writing it that way, I'm going to get lazy now that we're out of geometry class and we're in trig, and I'll probably say A plus B plus C equals 180. When we're writing letters on a triangle, we assign the angles the capital letters and the sides the small letters. And you'll notice here that side A and angle A are across from each other. They correspond. And it turns out that whichever angle is the largest will correspond to the longest side, and whichever angle is the smallest will correspond to the shortest side. So if we're given a triangle and we know two of the angles, let's say we have a triangle where angle A is 36 degrees and angle B is 53 degrees, we can quickly find out what angle C is by adding these two together. They add to 89 degrees. And then we can subtract that from 180 because we know that the triangle totals 180 degrees. So 180 degrees minus 89 degrees would be 91 degrees. So that's a quick, easy calculation. Another thing I'd like to talk about here is similar triangles. You may remember from geometry, similar triangles have the same angles. They have corresponding angles that are the same. So we see here that I have two little hash marks here with angle A, and that's going to correspond to angle X over here, which also has two little hash marks in it. Angle Y has one little hash mark, meaning it corresponds to angle B, and angle Z is going to correspond to angle C. Now what that gives us is a ratio between these two triangles. So filling out the rest of my sides here, we see that because these two are similar, because they have the same three measures of their angles, there's a ratio between A and X, and that's the same ratio as between B and Y, and the same ratio between C and Z. Now it turns out that we can actually flip all of these if we want, as long as we have either the large triangle all in the bottom and the small all in the top, or the large all in the top and the small all in the bottom. It doesn't matter. And what we'll find specifically with the law of sines is that I like to put what I don't know in the numerator. I find that's easier to solve. So looking at these two triangles we have a triangle with a 4 and a 10 and an unknown C, and we have a triangle with an X and a 22.5 and a 36, and I'm going to go ahead and tell you that these triangles, while I'm not saying that this is a right triangle, I am going to say that they are similar, meaning they have corresponding angles, or the same measures of their angles, and that means they have corresponding sides. So looking at, let's look for C. If I want to find C, I can go up here to my formula and I see that the ratio between C and its counterpart is the same as the ratio between, well, let's pick something we know both of. We know this side, we know both of those numbers, so that'll be what we look for. And since I've got C in the top, I'm going to put the 10 in the top. And since I've got the 36 in the bottom, I'm going to put the 22.5 in the bottom. And if I multiply both sides by 36, I get C equals 360 divided by 22.5 is 16. So we have just calculated that on this triangle, C would be 16. Alright, let's look at the other value we don't know, and that's x. Again, since we don't know x, I'm going to put it in the numerator because I find that easier. We'll look at x over its corresponding side, so the corresponding side would be 4, equals, and again we're going to look at the 22.5 and the 10, and in this case x is from the big triangle, so I'm going to use the number from the big triangle, 22.5, and then the 4 is from the small triangle, so I'm going to put the 10 down in the bottom. And now if I multiply both sides by 4, I get x equals 90 over 10, which I don't even have to use my calculator for that. That's 9. Alright, let's move on to the Pythagorean theorem. The Pythagorean theorem is a special theorem. It's only for right triangles, so we need to remember that. There is something similar to it that will work on any triangle. We call that the law of cosines, and that's going to be way at the end of the semester. So let's look at the Pythagorean theorem for a right triangle. If I have a right triangle, that means one angle is right, then my sides, C, A, and B, and it really doesn't matter which side is A and which side is B, but what does matter is that C is the hypotenuse. Alright, so it doesn't matter what we want to label A, what we want to label B. What does matter is that C is the hypotenuse. So whenever we have three sides of a right triangle, they are going to fit this relationship to where the square of one leg plus the square of the other leg equals the square of the hypotenuse. So let's try a few of these. So if we have a triangle with a side with a leg of 5 and a leg of 12, how do we find the third side? Well, c squared is going to equal 5 squared plus 12 squared. So c squared is going to be 25 plus 144. And that gives me c squared equals 169. Now, back in algebra, we would have said that that means c equals, the square root property says c would be plus or minus the square root of 169 or plus or minus 13. But right now, we're not going to consider the positive and negative. We're just going to go with the positive because it doesn't really make sense to say that a hypotenuse is a negative number. When we get into vectors, then that'll change a little bit, but for right now we're only going to use the positive numbers. Let's look at another example. How about 15 and 30 and an unknown value down here? Again, we could call it A or B, it doesn't matter as long as it's not the hypotenuse. One of the things that trips people up is they want to say that, I'm going to use this funky color just to show you that it's not right. They think that if you grab the two numbers, you just always add their squares. And that's not true. For one thing, when you do that, you're going to end up with a number that's bigger than 30. And the hypotenuse has always got to be the largest number. So let's not go there. Let's look at our a squared plus b squared equals c squared. So that gives us 15 squared plus b squared equals 30 squared. When we do this, we get 225 plus b squared equals 900. Now we need to subtract the 225 from both sides. B squared equals 675. And now we can use our handy dandy calculator to try to figure out what that's going to be. B is going to be the square root of 675, and depending on your calculator, it might tell you that that is 15 times the square root of 3. If not, you can always start off by pulling a 25 out. And 675 divided by 25 is 27. And so this would be 5 times the square root of 27. And then we can see that there's a 9 hiding in there, so it'd be 5 times the square root of 9 times the square root of 3, which would be 5 times 3 times the square root of 3, which is 15 square root of 3. If you struggle with some of these things, such as simplifying rational expressions, may I suggest that you look into the TI 36X Pro. It's an excellent calculator, and it will simplify radicals, it'll simplify rationals, it'll give you nice numbers for your trig functions, and it is a nice all-around calculator. I know some people will take that calculator along with a graphing calculator and use them both in a class. At this point, you can continue on to the angles, triangles, and Pythagorean theorem homework.